In parts 1 and 2 of this series, we tested some latex gloves and some cheap generic gloves to find out what their anti-static properties were. And I just wasn't satisfied with them. First of all, using the megohm generator here that can generate up to 1,000 volts, these things were painful. I felt in my homemade wrist strap here, incidentally, just to remind you, I'm using this homemade wrist strap because it doesn't have, as a regulation wrist strap does, a 1 megohm resistor built into it. This thing has no resistance of any practical value except what's in my hand. And when I use the generator wearing these, it got really painful because there's actually very little resistance from the surface of these gloves to your hand, especially when you're sweating inside these things. So don't use latex gloves if you want to protect electronic components from static discharge. These cheap cloth gloves also had very little resistance. The standard says, as far as I can tell, you want between 1 megohm of resistance or 100,000 ohms and 20 megohms. The base that I've set is 1 megohm and 20 megohms. These did not measure up. In addition, they're so thin that if you sweat through these, the oil from your hands is going to get on the enamel or of any PCBs you're working on or any electronic components, and the oil from your hand can damage those components. So if you wear these for any amount of time and you start sweating in them, they're cloth, and the sweat is going to be absorbed by them. The oils from your hand are going to be absorbed by them. It'll get onto the PCBs. They're good for short-term work, and they're cheap, so they're disposable. So I don't know, maybe they're okay for a lot of applications, but I just don't want to use them. So now we want to test some gloves that are meant to be used in ESD applications, working with electronic components. We've got these nitrile-coated gloves, polyurethane-coated gloves, and nitrile gloves. So let's find out how these things work. First gloves that we're going to test here are these DEX Fit nitrile work gloves. They've got a nitrile coating back. It's a very tight weave, so they may last a little while. Put this on. I'm getting the large size next time. They're fairly snug. They're not too tight, but if you're working with these for several hours, well, could get a little bit tiring. But let's see. Again, we've got this steel bar connected to the positive side of the megohm generator, and we'll connect my wrist strap to the negative lead from the generator. And let's see what kind of resistance we have. First of all, at 500 volts, the resistance of these gloves from the surface of the glove to my hand is about 1 megohm. It's a little bit over 1. No, it's about, I'm sorry. We want to use the middle scale at 500 volts. So it's about 600, 700,000 ohms. That's getting up there. According to some standards, these are good enough. In other words, they'll pass a charge, allow you to dissipate whatever charge you build up on your hand, and allow conductivity between you and whatever components you're working on. It'll dissipate a charge and allow you to so these are almost up to my standard, and they're fairly comfortable, they're fairly sturdy. I could probably use them. And remember, my baseline standard of 1 megohm is completely arbitrary. There are a lot of different standards out there, a lot of different testing procedures, and so I just had to pick a number, and I picked 1 megohm as my baseline. And I think it's a fair estimate of what gloves should be. Of course, if you've got a different idea or you know more about this stuff than I do, Milcoast breathable, ultra-thin, flexible gloves with a polyurethane coating. Now, they're not advertised as being ESD-safe. They're not meant to be used when working with electronic components, sensitive electronic components. But let's just see how these behave. At 500 volts, their resistance is way over 50 megohms. That's outside the standard. Well, it's about 50 megohms. That's at 500 volts. At 1,000 volts, now we're about 40 megohms. Yeah, about 40 megohms. That's above the standard, as I understand it. So that's why these are not suitable for working with electronic components. They have too much resistance and will dissipate whatever charge you build up too slowly. So let's try some Milcoast gloves. And incidentally, I'm not being paid to mention any brand names. I'm not being paid anything for this. I bought these gloves myself just to test different kinds. So the gloves we're going to test now, they don't have a polyurethane coating. These, well, I'm sorry, they do have a polyurethane coating, but they have carbon fiber woven into the cloth. And they're meant to be used when working with devices that are static sensitive. So let's see how these behave. These are the large size. And for my hand, they're very comfortable, not very tight, but let's see what happens here. You can see here, they're not, there's a little, they're sort of porous. You can breathe through them, especially on the back. It's a fairly tight weave. They're fairly sturdy. So let's see what happens at 500 volts. The resistance is, at 500 volts, these things have a resistance of about 150, 200 kiloohms, right around in there. That's above the baseline 100 kiloohm standard that I've read. It's still below what I like. What I said is my baseline of 1 megohm. They'll conduct electricity. They'll allow a voltage to pass through them. You can dissipate it fairly rapidly, but not so rapidly that you'll feel a shock. Let's try them at 1,000 volts. I'm not feeling anything in my hand right now, but the resistance in this circuit at 1,000 volts is Oh, about 250 megohm, 250 kiloohms. So they're above the base of some standards, and they're very comfortable. So they're probably good to use. But let's find out how they compare to these nitrile gloves right here. Accelerator-free disposable nitrile gloves, medium pack of 50 for, well, less than $6. These are the medium size, so they're too tight for me. If you've got an 8.5 to 9-inch hand around the knuckles, get the large size. Now these breathe. In other words, you're going to sweat in them a little bit, but the sweat isn't going to build up as much as it will with the latex gloves. And they will conduct electricity. So all right, we're connected. Let's find out what the resistance of these gloves is at 500 volts. Whoa! Whew. That was painful. Yeah. Just a little turn there. And I was feeling a powerful charge in my hand. Now about the voltages that I'm using here. The tests that the descriptions of the tests that I've seen say you want to test under different conditions, 1.5 to 10 volts or between 10 and 100 volts. And I'm testing a lot higher than that because I figure, well, a static discharge can be from 3,000 to 5,000 volts, or 3,000 to 30,000 volts. So testing at those low voltages, I don't know. I'm not an electrical engineer. I'm a network administrator. I don't know anything about this stuff. But it just didn't make sense to me to test at those very low voltages when static discharge can be so high. So I'm using somewhat higher voltages. And I've just found out that these are very conductive. Let's find out at 5 volts what the resistance of these gloves is. Way above the scale. Don't know what it is. Let's test using the fluke and see if we can get a measurement of the resistance of these gloves. Let's see. Connect the wrist strap commonly to the fluke. And I'll see, we'll connect the positive lead of the fluke to the steel bar. The resistance in this is about 1.5 megohms. Well, it's going down, probably going down as I'm sweating in them. It's down below 1 megohm right now. It's still pretty high. Well, it's going down fairly rapidly there. We're down to 0.5 megohm. So these gloves don't offer infinite resistance or even very high resistance. This is probably going down as the sweat builds up from my hand in these gloves. But they're advertised as ESD-safe. They obviously pass a charge, and will help you protect the electronic components that you're working with, as long as you're wearing a proper wrist strap and you're connected to a common connection with the electronic components, so that the potential between whatever charge you've built up and the electronics you're working on is the same. Now these, again, you build up sweat on your hands, and if you're working with electronics for a long period of time, that's not very comfortable. I'm going to go with these Milcoast carbon fiber polyurethane coated gloves. They're not up to my 1 megohm baseline, but they do have reasonable resistance. They'll allow you to dissipate an electronic charge or an electrical charge that you build up, and they breathe. They're fairly sturdy. So I've decided these are the gloves that I'm going to use. Anyway, I hope you've gotten something out of this. It's been a learning experience for me, and I know that 1,000 volts, even at a very small current, can be rather painful. But it was fun. Thanks for watching.